Welcome to Math with Mr. J. In this video, I'm going to go through an introduction to equivalent fractions. We will talk about what equivalent fractions are, how to find equivalent fractions using fraction strips, models, and number lines. And then our last section will be identifying equivalent fractions. Let's start by taking a look at what equivalent fractions are. Now, simply put, equivalent fractions are fractions that represent the same amount. They represent the same part of a whole. So basically, we can have fractions that have different numerators and denominators, so different top numbers and bottom numbers, but the fractions can still represent the same amount, the same part of a whole. In other words, equivalent fractions represent the same value. But how does that work? Well, let's jump into some examples and see. We will start with number 1, where we have who ate more, Louis or Lucy. So Louis and Lucy both have a grilled cheese. Both are the same exact size, so they are both starting with one whole grilled cheese. Louis's grilled cheese is that top square, and then Lucy's grilled cheese is the bottom square. Now, Louis cuts his into 2 equal pieces, so halves, and Lucy cuts hers into 4 equal pieces, so fourths. Let's see what that looks like. So here's Louis's grilled cheese cut into 2 equal pieces, and Lucy's cut into 4. Now, Louis eats 1 piece, and Lucy eats 2. Let's see what that looks like. So here's Louis's grilled cheese after he ate 1 piece, and here's Lucy's grilled cheese after she ate 2 pieces. Let's start by taking a look at Louis's. What fraction of Louis's grilled cheese was eaten? Well, Louis's grilled cheese was divided into 2 equal pieces. So 2 is our denominator. Then Louis ate 1 of the pieces. So 1 is our numerator. Louis ate 1 piece out of the 2 total pieces. So our fraction is 1/2. Louis ate 1/2 of the grilled cheese. Now let's take a look at Lucy's grilled cheese. What fraction of her grilled cheese was eaten? Well, the whole grilled cheese was divided into 1, 2, 3, 4 equal pieces. So 4 is our denominator. Then Lucy ate 1, 2 of those equal pieces. So 2 is our numerator. Lucy ate 2 pieces out of the 4 total pieces. So our fraction is 2/4. She ate 2/4 of the grilled cheese. Now back to our original question. Who ate more? Louis with 1/2 of the grilled cheese or Lucy with 2/4 of the grilled cheese? Looking at the pictures, we can see that they ate the same exact amount, even though we have 2 different fractions here, 1/2 and 2/4. They represent the same amount, the same part of the whole grilled cheese. Now again, Louis ate 1/2 and Lucy ate 2/4. 1/2 and 2/4 are equivalent fractions. And we can show that they are equivalent fractions by putting an equal sign in between. Even though Louis only ate 1 piece and Lucy ate 2, Lucy's pieces were smaller because she cut her grilled cheese into fourths. So those 2 pieces were equal to Louis's 1 piece. So to wrap this up, both ate the same part of the whole grilled cheese. And we showed that with our equivalent fractions, 1/2 and 2/4. Let's move on to another example and take a look at number 2. Taking a look at number 2, we have 2 pizzas. We have Ellie's pizza and Joe's pizza. Who has more pizza left, Ellie or Joe? Taking a look at the pictures, we can see that Ellie and Joe both started with the same sized pizza. And we can also tell that they have the same amount of pizza left. But each pizza has a different amount of slices. Now let's write out fractions to represent the amount of pizza left. And these are going to be equivalent fractions because they are representing the same amount, the same part of the whole pizza. We will start with Ellie. Ellie's pizza was divided into 1, 2, 3, 4 equal slices. So 4 is going to be the denominator. And then 1 slice is left. So 1 is our numerator. So Ellie has 1/4 of the pizza left. Now for Joe's pizza. Joe's pizza was divided into 1, 2, 3, 4, 5, 6, 7, 8 equal slices. So 8 is the denominator. And then 1, 2 slices are left. So 2 is the numerator. 2/8 of Joe's pizza is left. Now 1/4 and 2/8 are equivalent. So those fractions represent the same amount, the same part of the whole pizza. And we can see that Ellie and Joe have the same amount of pizza left, even though we have different fractions here. Let's take a look at one more example and move on to number 3. Taking a look at number 3, we have what fraction of each garden has flowers? So we have 2 rectangular gardens here that are the same size. Garden A and Garden B. So what fraction of each garden is filled with flowers? Now we can see that the same amount, the same part of each whole garden is filled with flowers. So we're going to have equivalent fractions here. Let's start with Garden A. Garden A is divided into 1, 2, 3 equal sections. So 3 is our denominator. And then 1, 2, 2 of those sections are filled with flowers. So 2 is our numerator. 2/3 of Garden A is filled with flowers. Now let's take a look at Garden B. Garden B is divided into 1, 2, 3, 4, 5, 6 equal sections. So 6 is our denominator. And then 1, 2, 3, 4 of those sections are filled with flowers. So 4 is our numerator. 4/6 of Garden B is filled with flowers. 2/3 and 4/6 are equivalent fractions. Both of those fractions represent the same amount. And we can see that shown here with the gardens. We have different fractions, but again, they represent the same amount, the same part of the whole garden. So another example of equivalent fractions. So there's what equivalent fractions are. Let's move on to finding equivalent fractions using fraction strips. Now let's take a look at finding equivalent fractions using fraction strips. And remember, fraction strips are a tool we can use to help us with fractions. They help us visualize fractions. Now here are the fraction strips that we are going to use in this video. We start with one whole, and everything is based off of this whole rectangle. Then we have the whole rectangle divided into 2 equal parts, so halves. Then the rectangle is divided into 3 equal parts, so thirds. Then 4 equal parts, so on and so forth, all the way down to 10 equal parts. Let's jump into number 1, where we have 2 fraction strips, and we need to figure out the equivalent fractions here. We have 1/3 is equivalent to how many sixths? So as far as the top fraction strip, we can see we have one whole rectangle divided into three equal parts. Each part is 1/3 of the whole. Now, only one part is shaded in, so this fraction strip is showing 1/3. So we have 1/3 written out right here. For the fraction strip underneath, the whole rectangle has been divided into 6 equal parts. Each part is 1/6 of the whole. Now, two of the parts are shaded in, so this fraction strip is showing 2/6. Now, notice, and this is really important, each fraction strip is representing the same amount of the whole rectangle, the same part of that whole rectangle. Both have the same amount shaded in, even though we have different fractions here, 1/3 and 2/6. These are equivalent fractions, and the fraction strips help us see that. Moving on to number 2, we have 1/2 is equivalent to how many eighths? Well, let's start with the top fraction strip. That whole rectangle has been divided into 2 equal parts. Each part is 1/2 of the whole. One part is shaded in, so our fraction is 1/2. For the other fraction strip, the fraction strip below, it has been divided into 8 equal parts. So each part is 1/8 of the whole. 4 parts are shaded in, so our fraction is 4/8. 1/2 and 4/8 are equivalent fractions, and we can see that with those fraction strips. Let's move on to some more examples. Let's take a look at number 3, where we have a top fraction strip divided into 8 equal parts, and 6 are shaded. So that's 6/8. That's going to be equivalent to how many fourths? Well, the bottom fraction strip is divided into 4 equal parts, and 3 are shaded in. So 6/8 is equivalent to 3/4. And we can see both fraction strips are showing the same amount, the same part of the whole rectangle. 6/8 and 3/4 are equivalent. Moving on to number 4, we have a top fraction strip divided into 6 equal parts, and 3 of those parts are shaded. So that fraction strip is showing 3/6. And that's going to be equivalent to how many eighths? Well, the fraction strip below has been divided into 8 equal parts, and 4 are shaded. So 3/6 is equivalent to 4/8. Moving on to number 5, the top fraction strip, we have 6 equal parts there, and 4 are shaded in. So that fraction strip is showing 4/6. And that's going to be equivalent to how many thirds? Well, the bottom fraction strip, we have 3 equal parts, and 2 are shaded in. So that's 2/3. Both fraction strips are showing the same amount, the same part of the whole rectangle. So 4/6 and 2/3 are equivalent. Lastly, let's move on to number 6. The top fraction strip has 4 equal parts, and 2 are shaded in. So that fraction strip is showing 2/4. That's going to be equivalent to how many halves? Well, the bottom fraction strip, 2 equal parts, 1 is shaded in, so that is showing 1/2. 2/4 and 1/2 are equivalent fractions. So there's how to find equivalent fractions using fraction strips. Let's move on to models. Here's our section on finding equivalent fractions using models. Let's jump into number 1, where we have 2 squares that are the same size, but each square is divided into a different number of equal parts. Now we can see that the same amount of each square is shaded in. These squares represent equivalent fractions, so let's write these fractions out. We'll start with the square on the left. The square on the left was divided into 1 2 equal parts. So 2 is our denominator. One of the parts is shaded in. So 1 is our numerator. 1/2 of the square is shaded. So this square is representing 1/2. The other square was divided into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So 8 is our denominator. And then 1, 2, 3, 4 parts are shaded in. So 4 is our numerator. 4/8 of that square is shaded in. So the square on the right is representing 4/8. Now, going back to what we talked about earlier, we can see that the same amount of each square has been shaded in, the same part of the whole square. So 1/2 and 4/8 are equivalent fractions. And we can write that out by putting an equal sign in between the fractions. Let's move on to number 2, where we have two rectangles that are the same size. And we can see that the same amount of each rectangle is shaded in. But each of those rectangles has been divided into a different number of equal parts. So we're going to have equivalent fractions here. Let's write out those equivalent fractions, and we will start with the rectangle on the left. It's been divided into 1, 2, 3 equal parts. So 3 is our denominator. And then 1, 2 parts are shaded in. So 2 is our numerator. 2/3 of that rectangle is shaded. So that rectangle is representing 2/3. Now, as far as the rectangle on the right, that's been divided into 1, 2, 3, 4, 5, 6 equal parts. So 6 is our denominator. And 1, 2, 3, 4 parts have been shaded in. So 4 is our numerator. So 4/6 of that rectangle is shaded in. That rectangle is representing 4/6. That means that 2/3 and 4/6 are equivalent fractions. Next, let's move on to number 3, where we have two circles. Now, the same amount of each circle has been shaded in. So we're going to have equivalent fractions here. Let's write those out. We'll start with the circle on the left. This circle has been divided into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So 8 is our denominator. 1, 2, 3, 4, 5, 6 parts have been shaded in. So 6 is our numerator. That circle is representing 6/8. Now the circle on the right has been divided into 1, 2, 3, 4 equal parts. So 4 is our denominator. And then 1, 2, 3 of those parts have been shaded in. So that circle is representing 3/4. So 6/8 and 3/4 are equivalent. Lastly, let's move on to number 4 and write out the equivalent fractions being represented here. We will start with the circle on the left. This circle has been divided into 1, 2, 3 equal parts. So 3 is the denominator, and 1 part has been shaded in. So 1 is the numerator. That circle is representing 1/3. Now for the circle on the right, it's been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. So 9 is the denominator. And then 1, 2, 3 parts have been shaded in. So 3 is our numerator. That circle represents 3/9. So 1/3 and 3/9 are equivalent. So there's how to find equivalent fractions using models. Let's move on to number lines. Now let's take a look at finding equivalent fractions using number lines. Let's jump into number 1 where we have two number lines. The top number line is showing thirds. There are 3 equal parts between 0 and 1. The bottom number line is showing sixths. There are 6 equal parts between 0 and 1. We're going to find two equivalent fractions here. 1/3 is equivalent to how many sixths? And 2/3 is equivalent to how many sixths? Now, as far as equivalent fractions on number lines, equivalent fractions are going to be at the same place on a number line, the same position. Let's start with part A of number 1. 1/3 is equivalent to how many sixths? So looking at 1/3, which is right here, right below, we can see that 2/6 is at the same place on the number line. 1/3 and 2/6 are at the same place between 0 and 1. They are the same distance from 0. So 1/3 and 2/6 are equivalent fractions. And we can see that with those number lines. Moving on to B, we have 2/3 is equivalent to how many sixths? 2/3 is right here. Well, right below, we can see that 4/6 is at the same place on the number line. 2/3 and 4/6 are equivalent fractions. Let's move on to number 2, where we have 4/8 is equivalent to how many halves? The top number line, we have eighths, and then the bottom number line, we have halves. 4/8 is right here. And we can see that 1/2 is at the same place on the number line. These are equivalent fractions. 4/8 and 1/2 are equivalent fractions. Lastly, let's take a look at number 3, where we have a number line showing fourths and a number line showing eighths. We're going to find 3 equivalent fractions here using these number lines. Let's start with part A. 1/4 is equivalent to how many eighths? Well, 1/4 is right here on the number line, and we can see right below that 2/8 is in the same place. These are equivalent fractions. 1/4 and 2/8 are equivalent. So that was A. Now let's move on to B, where we have 2/4 is equivalent to how many eighths? 2/4 is right here on the number line. And if we look right below, we can see that 4/8 is at the same place. These are equivalent fractions. 2/4 and 4/8 are equivalent. And then lastly, for C, we have 3/4 is equivalent to how many eighths? 3/4 is right here on the number line. And then looking right below, 6/8 is at the same place on the number line. 3/4 and 6/8 are equivalent fractions. So there's how to find equivalent fractions using number lines. Let's move on to identifying equivalent fractions. So here's our last section, identifying equivalent fractions. So for the examples in this section, we will be given a fraction, and then we need to identify all of the equivalent fractions. Keep in mind, there may be more than one correct answer for each example. Let's jump into number 1, where we have which fractions are equivalent to 4/8. And we have 4/8 shown right here with a pie. There were 8 pieces in total, and 4 are left. So 4/8 of the pie is left. We need all of the equivalent fractions. So all of the pies with the same amount left. The same part of the whole pie left. Let's start with choice A, 1/2. Is this equivalent to 4/8? Is the same amount of pi left? Do we have the same part of the whole? Looking at the pictures of the pies, yes, we do have equivalent fractions here. These fractions represent the same amount, the same part of the whole. So 4/8 and 1/2 are equivalent fractions. Let's move on to choice B, where we have 2/6. So is 2/6 equivalent? No, this is less than 4/8. We do not have the same amount here. So this is not equivalent. Moving on to choice C, 3/6. Is this equivalent? Yes, we have the same amount of pi left. These fractions represent the same part of the whole pie. 4/8 and 3/6 are equivalent fractions. And lastly, D, we have 2/4. This is the same amount as well. So 2/4 is an equivalent fraction. 4/8, 1/2, 3/6, and 2/4 are all equivalent fractions. They represent the same amount of the whole pie, the same part of the whole pie. Let's move on to number 2. Taking a look at number 2, we have which fractions are equivalent to 1/3. And here is a model of 1/3 right here that we can go off of. One equal part is shaded in out of the 3 total equal parts. Let's start with A, 2/4. Is 2/4 equivalent? No. 2/4 is greater than 1/3. We can see that more of the rectangle is shaded in. A greater amount, a greater part of the whole rectangle is shaded in. So this is not equivalent. How about B, 2/6? Is this an equivalent fraction? Yes, this is equivalent. The same amount of the whole rectangle is shaded in. 2/6 is an equivalent fraction. Moving on to C, we have 1/8. Is that an equivalent fraction? No, 1/8 is less than 1/3. Less is shaded in. So 1/8 is not equivalent. And then lastly, for D, we have 3/9. Is 3/9 equivalent? Yes. We have the same amount of the whole rectangle shaded in here. So 3/9 is an equivalent fraction. So 1/3, 2/6, and 3/9 are all equivalent fractions. Let's move on to our last 2 examples, numbers 3 and 4. Taking a look at numbers 3 and 4, let's start with number 3, where we have which fractions are equivalent to 3/4. And here we're going to be working with number lines to help us out. Remember, equivalent fractions are going to be at the same place, the same position on a number line. So we have our number line with 3/4 marked. Let's go to A, 5/8. 5/8 is right here on the number line. So is 5/8 equivalent to 3/4? Is it in the same place on the number line? No, 5/8 is not equivalent to 3/4. Let's move on to B, 2/3. 2/3 is right here on the number line. Is it at the same place on the number line as 3/4? No, it's close, but not quite. So 2/3 is not equivalent. Moving on to C, we have 4/6, which is right here on the number line. So is 4/6 equivalent to 3/4? No, it's not in the same place on the number line. So this is not equivalent. Now I do want to mention, looking at 2/3 above, notice that 4/6 and 2/3 are equivalent though, but that's not our question here. Lastly, let's look at D, where we have 6/8. 6/8 is right here on the number line. And we can see that it's at the same place as 3/4 on the number line. 6/8 is equivalent. So for number 3, 3/4 and 6/8 are equivalent fractions. Moving on to number 4, we have which fractions are equivalent to 4/6. And we have a model to go off of right here. 4/6 of that rectangle is shaded. Let's start with A, where we have 2/3. And we just talked about these fractions in number 3, actually. 2/3 is equivalent, and we can see that with this model. The same amount, the same part of the whole rectangle is shaded in. So 2/3 is equivalent. And we saw that with the number lines in number 3. Let's move on to B, where we have 3/4. Is 3/4 equivalent? No, 3/4 is greater than 4/6. A greater amount of that rectangle is shaded in. So this is not equivalent. Taking a look at C, we have 8/12. 8/12 has the same amount of the rectangle shaded in. So 8/12 is an equivalent fraction. And then lastly, choice D, we have 3/5. Is 3/5 an equivalent fraction? No, 3/5 is less than 4/6. Less of the rectangle is shaded in. So this is not equivalent. So there you have it. There's an introduction to equivalent fractions. I hope that helped. Thanks so much for watching. Until next time, peace.